The discovery hit the astronomical community like a shockwave. When NASA publicly released the newest set of James Webb Space Telescope data concerning the interstellar object known as 3I Atlas, what had once seemed like a fascinating curiosity suddenly became something far more profound and far more unsettling. For years, scientists had debated whether interstellar visitors such as Oumuamua and Borisov were merely odd remnants of distant solar systems or something that hinted at a deeper, stranger cosmic story. But the James Webb Telescope, with its unmatched sensitivity and ability to probe distant worlds in unprecedented detail, has now given humanity its clearest look yet at such an object. What Webb saw in 3I Atlas was nothing short of astonishing, and in some ways deeply troubling. Before we start, smash the like and subscribe buttons for more updates. When 3I Atlas was first detected in 2024, astronomers recognized it immediately as only the third confirmed interstellar object ever observed passing through our solar system. Its trajectory was unmistakably hyperbolic, meaning it could not possibly be gravitationally bound to the Sun. It had come from the stars, a wanderer flung across the cold depths of interstellar space. Early telescopic observations showed an object that seemed faint and irregular, but its surface composition was difficult to determine. Ground-based telescopes hinted at unusual reflectivity patterns, something that did not quite match the dusty, icy profiles of known comets or the rocky, metallic fingerprints of asteroids. For 2 years, astronomers eagerly awaited the chance for the James Webb Space Telescope to point its golden mirrors toward 3I Atlas and collect real spectra. That moment finally arrived, and the results immediately forced researchers to question fundamental assumptions about how such objects form. What Webb revealed first was its spectral signature, a detailed analysis of the wavelengths of light reflected and emitted from its surface. Instead of the expected combination of carbonaceous compounds, silicates, and frozen volatiles, Webb's infrared sensors returned a complex and almost engineered pattern of absorption lines. The data suggested layered materials, metallic in nature, but interspersed with organic residues of a type that had never been catalogued before. Certain bands corresponded to alloys used in spacecraft manufacturing on Earth, but at ratios impossible to produce naturally in known astrophysical processes. This peculiar composition was not immediately declared artificial. But even the most cautious researchers admitted that 3I Atlas did not behave like a normal body shaped only by geological or chemical evolution. The shape of 3I Atlas, reconstructed from Webb's high-resolution imaging, only deepened the mystery. It was extremely elongated, with a length-to-width ratio of nearly 10:1, and featured abrupt angular facets that did not fit the smooth curvature typically seen in natural tumbling asteroids. One of the most striking details came from how it reflected sunlight. The reflectance curve fluctuated rhythmically, almost like a rotating beacon, with precise periodic intervals that remained consistent over days of observation. Such regularity could theoretically arise from natural tumbling, but the light modulation was too stable, too deliberate. Some scientists compared it to the way engineered satellites flash as they rotate, hinting that 3I Atlas might not be an ordinary chunk of rock at all. Then came the thermal readings. Webb's mid-infrared instrument, MIRI, detected heat emissions that did not correspond to what should have been expected from a passive body merely absorbing and re-radiating sunlight. Certain regions of the object were warmer than surrounding ones, and these thermal patches shifted over time in a pattern that could not be explained by rotation alone. At first, teams proposed that volatile outgassing, similar to a comet venting jets of gas, might account for the phenomenon, but follow-up observations detected no trace of water, carbon dioxide, or other typical cometary compounds. Instead, there was an odd infrared glow at wavelengths commonly associated with energy conversion, something more akin to radiative dissipation from an active system than a natural emission. NASA's internal analysis team, working jointly with the European Space Agency and several university partners, spent weeks rechecking the data. Calibration errors were ruled out. Instrument noise was negligible. Webb's pointing stability ensured the readings were genuine. When the findings were finally compiled, they painted a picture that defied conventional astrophysics. 3I Atlas appeared to have internal heat sources potentially powered by mechanisms that did not fit any known model of natural radioactivity or frictional heating. The object's density, inferred from its motion and light curve, was anomalously low, similar to hollow structures rather than solid rock. Combined with its reflectivity, geometric precision, and energy signatures, the implications were staggering. As the data became public, debates erupted across the scientific world. Could this really be evidence of an artificial interstellar probe? Was it possible that 3I Atlas was some ancient relic from another civilization, perhaps long inactive, drifting through space for millennia? While NASA avoided sensational conclusions, the language in their technical brief was unusually cautious. It described non-natural spectral regularities and unexpected thermodynamic behavior, terms that hinted strongly that the agency had found something outside the realm of ordinary astrophysics. Independent astronomers quickly began to analyze the released datasets themselves, and many found corroborating signs of structured composition. The ratios of nickel to chromium, the spectral dips near 1.2 and 2.8 micrometers, every detail seemed to whisper that 3I Atlas was built, not born. The implications of this possibility struck at the very heart of humanity's understanding of its place in the cosmos. If 3I Atlas were indeed artificial, it meant that technological civilizations had existed elsewhere long before humanity's rise, capable of constructing interstellar probes that could survive the ravages of cosmic radiation and time. Even more troubling was the thought that it might not be inert, that the strange heat signatures could indicate continuing operation, however faint. Was it transmitting, observing, repairing itself? The James Webb Telescope could only see what was visible from afar. It could not answer those questions. But the mere suggestion that something built by alien hands was moving silently through our solar system sent a chill through every scientific institution on Earth. Some theorists proposed that 3I Atlas might be part of a vast network of probes sent out eons ago to map and monitor the galaxy. Others argued that the object could be debris, the broken fragment of a once functional vessel, its strange composition the result of ancient engineering. A smaller but vocal group of skeptics urged caution, noting that exotic but natural explanations might still exist. Perhaps unusual crystal lattices or metallic condensates could form under extreme interstellar conditions, creating the illusion of artificiality. Yet even these skeptics had to admit that the combination of shape, structure, and energy behavior was uniquely baffling. As the telescope continued to track the object, a new layer of complexity emerged. 3I Atlas's motion through the solar system did not perfectly match the trajectory predicted by gravity alone. Subtle but measurable deviations were recorded, tiny accelerations inconsistent with radiation pressure or outgassing. The data echoed the same mystery that had surrounded Oumuamua years earlier, which also exhibited unexplained non-gravitational acceleration. But this time, the precision of Webb's instruments eliminated the margin for error. The object was moving as though some internal mechanism adjusted its course, however slightly. That realization reignited the debate over whether 3I Atlas could, in essence, be a machine. Engineers studying the thermal maps noticed that the hot zones on 3I Atlas aligned with the direction of its motion, suggesting that they might serve a functional purpose, perhaps propulsion or orientation control. The emissions were faint, orders of magnitude below anything resembling an active engine, but still distinct enough to imply control rather than chaos. If this were a derelict craft, it might be operating on residual power, its systems flickering to life intermittently after unimaginable ages of drift. Some even speculated about self-repairing nanostructures or autonomous subsystems designed to sustain minimal function indefinitely. In the language of engineering, it seemed less like an asteroid and more like a drifting relic of design. Yet the unsettling part of the data was not just its hint of intelligence, but its implications for time. Based on trajectory modeling, 3I Atlas appeared to have entered our solar system from a region of interstellar space devoid of any nearby stars within a few light years. That meant it had been traveling for millions, possibly billions, of years.